In these examples, we'll be substituting values in algebraic expressions. So we have this expression, w squared plus 2w minus 4. The variable w is being given a value of -7. So what we're going to do now is we're going to plug in the value of -7 every place where there is the variable w. And we're going to wrap these variable values inside brackets just to avoid any issues with negative numbers. So we have in brackets -7 to the exponent 2 plus 2 times -7 minus 4. We start with the exponent according to the rules of BEDMAS, and -7 times -7 is positive 49, plus 2 times -7 minus 4. The next step is to do the multiplication, and that involved multiplying 2 times -7, gave us the -14. The plus a -14 becomes a -14 minus 4, giving us a final answer of 31. Now, I'm going to illustrate here just why using the brackets when substituting for a variable is important. So once again, we have the variable w in an expression w to the exponent 2. And we're saying w has a value of 7, so we're going to plug that -7 in everywhere a w existed in the expression, giving us something that looks like this, which is the same as saying -7 times -7. That's basically what -7 to the exponent 2 is saying, giving us a value of positive 49. Compare that to an expression where there was no bracket. Let's just say we saw something like this in an expression where we said -7 to the exponent 2. That exponent 2 only applies to the number it's next to. Okay? It only applies to the 7 here, not a -7. And this changes things a bit. This would be the same as saying 7 times 7 and then adding the negative sign in front of it. It gives us a totally different answer. It gives us -49. I'm going to show this on a calculator now. We can demonstrate the importance of brackets on a calculator. If we took the number 7, -7, and raised it to the exponent 2, we were given the answer of -49. However, if we put the brackets in, raise it to the exponent 2 again, we're shown an answer of positive 49. So, putting the brackets in when we're substituting values for the variables can keep us out of trouble when we're using negative numbers. Let's try a somewhat more complex one. Here we have the expression x squared plus 3x plus y, where x is given a value of 5 and y a value of -3. Again, we'll substitute the actual values for the variables. And we're given 5 to the exponent 2 plus 3 times 5 plus -3. Once again, we'll do the exponent first. 5 to the exponent 2 is 25. Then we'll do the multiplication. 3 times 5 is 15. And then we'll add the negative 3, which is basically the same as saying subtract 3, to give us a final answer of 37. I hope these examples have helped.